All right, so to start off Unit 6, we're going to talk about this thing called molar mass. And this is going to fill in the top part of page 1. We'll actually finish the bottom part of page 1 in class. So, first off, remember mole. We've mentioned it before very briefly, but this unit is going to have a lot about the mole. So let's redefine it. The mole, which we abbreviate MOL sometimes, is the standard international unit for the amount of a substance. So that lets us compare how much of this or that we are reacting in a chemical reaction. Something like, oh, I have 1.5 moles of water or 3.22 moles of copper. Just the amount of stuff that we've got. Now, what we're talking about here is the molar mass. And the molar mass is actually the mass of 1 mole of atoms or molecules. Kind of like the name implies, the molar mass, the mass of a mole of anything that you've got. And the units for molar mass are going to be G/mol, grams per mole is how you kind of pronounce or read that out. If you want to say G/mol, you can. Some people say Gmol or start almost calling it Jamal. But we got to remember to put those units on our molar masses that we're going to be calculating today. And that's especially important that we remember that that's grams per mole, because very soon in this unit, and for the rest of our lives in chemistry, we're going to be using this molar mass as a conversion factor. So that's going to be telling us that molar mass number we add up today is how many grams we have per mole in 1 mole of that substance. So we'll remind you of that when we get to that part of our unit, but that's why we're taking the time to learn where these come from and practice calculating them, because they're going to be an important tool in our toolbox. And all that we really need to do to find a molar mass is add up all of the individual masses of the elements in the compound using the periodic table. And I'll walk you through the first few calculations, but really when it comes down to it, take all those numbers straight off the periodic table and don't round anything in this process. All of the numbers come straight from the periodic table. There are these little numbers underneath the element's symbol there. We're going to multiply them and add them, and at no point in this process are you going to round at all. They're not too long of a number, but we're going to keep all of those digits, so there should be no questions or issues with sig figs, at least so far in this unit. So let's go ahead and look at the first example. Cu is all that we're asking for the molar mass of first, and if you find Cu on the periodic table, that mass that's right underneath the Cu in the periodic table is 63.546. And that is the molar mass of Cu. If it's just 1 Cu, we just take that mass. That's our answer. Just got to remember to put grams per mole on it. If we have something like Cl2 in our second example, well, we can find Cl on the periodic table and find its mass is 35.453. But that's the mass of 1 Cl atom, or 1 mole of Cls. And here, this is Cl2. So guess what we've got to do to that number? Multiply it by 2, because 2 Cls will weigh twice as much as 1. So if we take that number times 2, we get 70.906, and that's our answer, at least as long as we put that grams per mole on it. Then with H2O, after we start getting multiple elements, still start by finding their masses on the periodic table. H is 1.008, oxygen is 15.999. I do have 2 H's there, so we are going to need to multiply that H value by 2 before we add it up with the mass of that oxygen, but that's all there really is to it. Take the formula, make sure you understand how many atoms of each element you have there. Take the mass from the periodic table, multiply it by how many you have, then add it up. And don't forget grams per mole, of course. So even with bigger, more complicated looking formulas, just focus on, I have 2 NAs, 1 S, and 4 O's. Just read that formula first and make sure you know how many atoms of each thing you got. Then we're going to go find our masses on the periodic table, Na, S, and O. Take Na times 2. S just comes over because there's only one of the S's. We've got 4 oxygens, so I take that 15.999 times 4. And once I've got all of those masses, For each individual element, we add them up, and our final answer is 142.042 grams per mole, of course. And then our final example here, Ca3PO42. This one's a little extra tricky because of these parentheses. So you've got to remember that when we put this PO4 group in parentheses with that 2 there, that means that we actually have 2 PO4s in that molecule, 2 of that entire group, which means you've got 2 P's and 4 O's in each set. And since we have 2 sets, 2 groups, that means 8 total oxygens there. You can think of this like distributing in that 2 from the outside of the parentheses gets multiplied by how many we already had of each element. So 2 times 1 was 2 P's, and then 2 times 4 is 8 O's. So knowing that and being confident with that, we find the mass of Ca, P, and O. We take Ca times 3, P times 2, and O times 8. And once we get all those masses, we add them up to find our final answer, 310.174 grams per mole. Pretty simple concept. It's not that complicated, but as you can see at the bottom of the page, we've got some names we're going to have to write the formulas of, and if we don't get the formula right, we can't get the molar mass right. So we are going to finish these examples in class. It's not something that you need to do to get your stamp, but that's really all there is to molar masses. Find the formula, count your atoms, multiply those numbers by the masses, and then add them up. So hopefully that's a nice, quick, easy, short podcast for you, and I'll see you in class as we finish page 1.